do this. Okay. So our topic is not very friendly. It's balancing redox. When you just read, because there are some rules that are there to guide you to balance redox. What we say on balancing redox is that you can actually balance it by inspection if you can. But the rule about redox is that it's a tricky way of balancing, because sometimes you can balance the atoms and yet the charges are not identical. Like especially if you have ionic equations, the charges must always be identical. On the left hand side, the charge must be the same as the charge on the right hand side. So like the simple redox, which we did last time, where you have sodium and chlorine, these ones are easy to balance. You can just balance by inspection. You can count the number of chlorines there and do all that. But then if an equation becomes more complicated, then there are these rules. So the first rule is you assign oxidation numbers. The first rule is you assign oxidation numbers. Like you have something like this. This one, if you're balancing by inspection, there's possibility that you spend a lot of time balancing, because just how to go about the oxygen, you find that everything else is balanced, but the oxygen is misbehaving. So for these ones, you have to assign the rules. So that's why we are doing those rules for balancing oxidation, for finding oxidation state. So like this is tin plus nitric acid, giving you tin 4 oxide plus nitrogen dioxide plus water. So you assign oxidation numbers to everything. Sometimes you can even ignore the oxygen, but it's okay to, you can assign everything. So you've seen that the tin was alone, so it's 0. Then this one is plus 1, you remember the rules, minus 2, plus 5 for the nitrogen. Then for this one, it's plus 4. This one is the nitrogen is plus 4. In the water, there is a plus 1 and a plus 2. You pardon me, you have to go through those things, guys. Nganamba okusolva mu again oxidation numbers to solve it. So you just have to have a book where we solve different oxidation numbers. Then you only isolate those atoms whose oxidation numbers have changed. E.g., tin is moving from 0. Tin is moving from 0 to plus 4. Then nitrogen is moving from plus 5 to plus 4 also. So meaning the one that has increased, which is the tin, which is 0 to plus 4, that one is oxidation. Then the one that has decreased, which is plus 5 to plus 4, that is the reduction. So you only write 2 equations, only including those things that have been oxidized and the other one which has been reduced. It doesn't matter which one you start with. So as you've seen, we've written them as charges. The oxidation numbers we've written as charges. So we've written SN0, meaning the oxidation number is 0, giving us SN4 plus, meaning there the oxidation number is plus 4. Then there it's N5 plus, giving us N4 plus. Then we'll balance these things with electrons. So the electrons must be equal to the difference in the oxidation numbers. So if this is 0, how was it 0? Because it was alone. So if this is 0, to go to plus 4, it means there's a loss of 4 electrons. Remember I told you that oxidation is loss. So meaning this one had lost 4 electrons. So you write SN0 giving us SN4 plus 4 electrons. Then N5 plus to 4 plus, the difference is 1 electron. So you add the electron for the reduction. The electrons are added on the left hand side. For the oxidation, they are added on the right hand side. So these are the balancing. That's all. So the only thing that you have to do now is you factor, because the electrons lost must be equal to the electrons gained. The electrons lost must be equal to the electrons gained. So since this one lost 4 electrons, so you find the factor. You multiply everything here by 4, so that there's 4 electrons here also. So like you do it the way they've said, they've done it there. You multiply by a factor. If there was 2 and 3, would have reciprocated, so that there's 6 on both sides. So this is the case. So it means you are done with all this. So all you do now is you remove now these things. It means you are done with dealing with the redox. So you move the coefficients here. You know that there's one here, there's one there. You can even put the ones there. So there's one there, there's one there. Then in front of the nitrogens, there are 4s. So you put a 4 there and a 4 there. So the only thing that remains to be balanced is now the water. You balance the water by now inspection. So you've seen that there is 4 times 3, which is 12 oxygen molecules. I'm sure you've seen that. Then there is 2. So what is 4 times 2? 8. 8 plus 2, 10. So the difference in the oxygens, that's how much you put here, a 2. Then you have balanced your equation. So this is how you balance this one, these ones. So I'll give you, there are so many ways of balancing these things. I'll go to what was in the Stud Master today. Example for acidic solution. For acidic solution. So when you're balancing this, the acidic solution one is very easy because it only has the things that are oxidized and reduced. So you get everything now. Unlike what we were doing previously. So you get the chlorate, we'll go with the chlorine. Then the sulfur dioxide will go with the sulfate ion, like that. So you get it. So if you write this, the first rule for this is you balance all atoms other than hydrogen or oxygen. So since they are already balanced, like sulfur is balanced here and sulfur is balanced here, and the chlorine is balanced there, then that's okay. You get it? So if you have this one and this one, one of the easiest rules that I can give you is that you've seen that on this side there's a 0 oxygen. Then on the other side there are 3 oxygens. So you balance the oxygens with water. So you add plus 3 H2O. You get it? The difference in oxygen, this is for acidic solutions, you add plus 3 H2O. On the opposite side, you balance a mesh. So when you balance that, then you balance the hydrogen. So you've seen that 3 times 2 is 6. So that's why you put 6H plus. Then after that, you balance the charge with electrons. You balance the charge with what? Electrons. It's a bit tricky to balance the charge with electrons because people fail to understand how many charges are there. But what charge do we have here? There are 6H plus, so it's plus 6. Plus 6 here, then there's a minus here on the charge there. If there was a number here, like say 3, it would have been minus 3. But then there's just one chlorate. Yes, Stephen?
So I don't know if it is me alone, but I don't know where you are. I can only see the screen which is stuck from where you were explaining earlier.
Oh, that's the thing, huh?
Yeah, sorry, I can't see what you are explaining.
All right. Guys. Can you see now?
Yes, sir.
Okay. So I was saying, if you have this thing, zoom, if you have this equation, this is acidic solution. So for acidic solution, it's very easy because in most cases, we only have the things that are oxidized and reduced. So you isolate the things that are similar. The chlorate with the chloride ion, the sulfur dioxide with the sulfate ion, if so, like this. Then I was saying, to balance here, the shortcut, if those of you can understand the shortcut, if possible, you can use the oxidation numbers. But before oxidation numbers, let me explain this other rule, which says if you have 3 oxygens here, then there's 0 oxygen here. The difference in oxygen, you add water. So since there's no oxygen this side and there are 3 this side, you add 3 H2O. You add 3 H2O. So when you add this 3 H2O, then you balance the hydrogen with like you balance hydrogen from the water. There's 3 times 2, which is 6. So you add plus 6 H plus A. So 6H plus. Then after that, you now balance the charges. The charge on this side must be equal to the charge on the other side. So since you kulika minus, nakaka minus, if there was a number here, say 3, nang 7, it would have been minus 7. Number padife, minus, minus. Then these things just have coefficients of 1. So it's minus, minus. So these two are cancelling out. But then there are these 6H plus. So to cancel out the 6H plus, you add plus 6 electrons. Then it means the charge here will be the same as the charge on the other side. Because you have cancelled the hydrogen with the electrons, then pashala ka minus na ka minus. Believe you me, guys, it's possible that tamule mfana sana for your redox. Tayumfika bwangu. But with practice, you understand the things I'm talking about. Mwijirimuka sana. Mwafaka guys, eh? Fya tinage redox mugala fidwe no redox tita sa nishita muletere po redox. So now these ones now for the sulfate, the same thing. We can say the difference in oxygen, okuli 4 oxygen, okuli 2. I'm sure you've seen. So the difference is 2. So you add plus 2 water this side. Then you balance the water with hydrogen. So since 2 times 2 is 4, so you add plus 4 hydrogen ions there. Then when you do this, you balance the charge. How do you balance the charge? You want the charge this side. Charge is 0. So you also want a charge of 0 this side. Since you have SO4, 2 minus, this is my negative 2. Then 4 times the plus, which is plus 4. So minus 2 plus 4 is plus 2. So plus 2, to cancel plus 2, you have to add 2 electrons. That's all. Then after this, you will see that the electrons, they are different. Okay, the electrons that are in this reaction must be the same as the electrons here. So to balance the electrons, you factor, okay, you have 6 and 2. So what number do you multiply where to get a uniform thing here? Okay, you want to get maybe the same number on both. So you discover that if you multiply by a factor of 3, 6. So you multiply everything with 3. So you're going to have 2 times 3, 6. Then upper 3, upper 3. Then upper 12, upper 6. Then after this now, you can add these 2 electrons. So when you're adding these 2 electrons, the electrons and the electrons here will cancel. Then I mean, state appear both sides. So you cancel out these 3 upper, ushare na 3 upper. Okay, 6 you subtract. 6 minus 3 is 3. So kwala wafe 3. Then also the same case for the hydrogens. Ukuli plus 6, upper multiply plus 6, upper plus 12. So what is 12 minus 6 is 6. So ukukuli 12 wala kansa kwa yali no. Then you shall oku na 6. Are there any questions? Are there any questions? Ain guys. Okay. So what I want to emphasize now is that other than using this water method, which to me is simple, is that you can also use oxidation numbers. So when you calculate the oxidation number here for the chlorate, so remember this is 3 times -2 minus 6, so this is plus 5. So plus 5, then ukuli minus 1. So ukuli plus 5, ukuli minus 1. Then hapa na pena, this is plus 4. Kai 2 times negative shani. 2 times kai oxygen. Remember oxygen number for oxygen is -2. So if we don't want to fill oxygen, for the redox. So the oxygen number for oxygen is -2. So what is 2 times -2? -4. So engine plus 4. Then upon a pen you can calculate what is 4 times -2, -8. -8 nga cross okunisha pala plus 6. So this is plus 6, then this is plus 4. So if you have oxidation numbers, so what you do is in plus 5. Now kwata plus 5. Kuiremba wale wakademba pamuru. Mule kwata koti pepa pa kusolve if. Then up minus 1. So what's the difference between plus 5 and minus 1? What is plus 5 minus 1? And guys?
Plus 4.
Plus 5 minus 1. Plus 5 minus 1. Eh? Plus 5. Plus plus 5 minus 1. Lemon somewhere.
6.
6. Stefan. So the difference here is 6. So arabikapo ukukudi ini reduction. So kwenye kuside walabikako plus 6 electrons. And difference, what electrons are you putting there? The difference in the oxidation numbers. My electrons would have so plus 6 electrons. So what are plus 6 electrons? You now balance the charge with hydrogen. Ngawakwatapa ukurife chlorine yeka, then ukuri minus 6. This is minus 1, there's minus 1, these are balancing. So you cancel out this charge here. So you say, what do you cancel out with? For acidic solution, you balance the charge with hydrogen ions. So that's why you say plus 6H plus. The 6H plus you have added is to balancing the electrons. When you balance that, ngawabi kapo hydrogen, then you balance now. The last thing is you balance the hydrogen with water by adding half of the hydrogens here. Kaya the 6H plus. So half of it kai trefa ibe ukube 6 hydrogen, so to 3H2O. So this is how you balance using oxidation numbers. That's why I was telling you it's better ukubombia mensh. A mensh is the same rule. We'll be practicing and practicing. I think even the next lesson on Friday is the same thing I'll come and talk about. So it's the same thing in pen. This we said is plus 6, ukuni plus 4. So plus 6 na plus 4, the difference plus 6 minus 4 need 2. So you add the electrons on this same side, ukudi 6. So at the same, you add 2 electrons. The electrons are equal to the difference in the oxidation numbers. Then after that, you balance the charge with hydrogen. So now mono kudi 0 charge. Then ukudi ka minus 2 kai 2 electrons are 2 minus. So minus 2 is minus 4. So plus 4H plus. Even when you open, guys, but I just don't want you move blank sana. Ninja na open and understand fions. But I don't want you to be too blank that yes, Mr. Chongo.
Yeah. On top of we have the equation which is showing the reduction process. Now down there we have the equation which is showing oxidation. Now I want to ask on the charges. On top we are putting the charges to the left hand side. then down you are putting the charges on the reduction equation. Let me say on the reduction equation, you are putting the charges to the reactants, and on the oxidation equation, you are putting the charges to the product.
Yes.
What if you interchange? Is it just is it a mandate that you do? You should just put them like in this way.
Yes, sir, because in oxidation, electrons are lost. So electrons must be the product in oxidation. In reduction, electrons are gained. So electrons must be the reactants in reduction. Now,
Sir.
Yes, Gordon.
Yeah, on the same question on the balancing, like the way you're explaining, let's say you have come up with the reaction for the redox.
Yes.
Then is it appropriate to balance first the F reactions with the electron? Then now you follow the concept which you stated to say every oxygen as one water molecule. So if it's 3, you consider that there are 3. But considering the fact that you have already balanced the electron F reaction, I don't know how that can be.
Go and try it out, but it's better to deal with an individual process alone. Mom for bossing. If it can work for you, Kai, the idea is in the end it should be balanced. So if you that's what I feel myself. But you, if you feel like then put a balance ama redox it can also work. If it can, do it. Mom for Tatawa Godin.
Yeah, I'm quite sure.
Okay. Tandio.
Yes, sir. Sir, someone told me that when an element or turn is alone, independent, the oxidation number is always 0. Is that applicable to even those?
To what?
Now my question is it applicable to those elements that already have the constant exact turn oxidation number?
Mami, like
let's take oxygen for it.
Oxygen gairieka ni 0 mayo.
No.
Just a O2 is 0. Any element. Oh, marisaru fyano kumutarika mayo. Kai momuli bafitala mayo batandiwe. Timwatarika but amfire mamutarika iyo. Alema fye chinka. If the number is the element is alone, except the rules to ananimpere for ions, the oxidation number is equal to the charge on the ions. Are you getting it?
Yes.
Yes. So, but oxygen ilieka O2, nango hydrogen ilieka H2, nango ozone so O3, oxidation number is 0. But when they are in compounds, that's when they have that fixed oxidation number we talked about. Like in water now, that's when it will be like apanomba so in this, that's when it will be -2. There was a hand in station. Na ipano kwenye fiawa meftevo nadi mifuluka guys munjelele ko mamvale nadi mifuluka vesana
nako bene
mama chikota hand up.
Yes sir.
Robert tamachumva dia
no
Mofi Google coffee data because I'll put the same things that I've put here. The things that I've said, I'll put them also on YouTube, these things. But what I want to encourage you is oxidation states, you learn them by practicing and practicing and practicing. The first time, but with time, it will be easy. So to summarize what I talked about is, we can use electrons, we can use oxygen. One of the things that I want to emphasize is ngamwamona kwati soy S8. S8. The first thing you do is kubalansa. You balance elements other than hydrogen or oxygen. Balance. So you have to put 8 here. But in oxidation number upon is 0. Imagine oxidation number upon is 0. Why? Because the sulfur is combined to itself. So then you do all those things. So apa ini +1. So in -2. So I'm going to put 8 up. 8 times -2 is 16. So you have to add 16 electrons. Bamondemayo.
Yes, sir. Is it that when balancing on number 2,
Yes.
we can put the hydrogen and the water wherever we want, or it's mandatory to put the hydrogen on the left side and the water on the right side?
On number 2, E. Okay. So for this one, umutamuli na hydrogen, umutamuli oxygen. You only add water where there is oxygen. Water is that.
I'm saying when balancing.
When balancing, yes, the rules are almost mandatory. But sometimes you have to use your own tact. You see that ukutakuli hydrogen, takuli water idionsem, kwa number 2 up. It means you just stick with the hydrogen. When you just add hydrogen, everything is balanced. So it means you have to move to another thing. But for this one, the difference in water, like there's 3 upper 2, it means you have to add +2 water, the other side. Then you balance the hydrogens, ballast. The rules are almost the same things. You do the same things all the time. I'll be back on Friday to say the same things. Namubale, Muitina san. I'll organize myself on Friday. I'll be back to say the same things.
Sir,
We together.